In this question, we're asked to solve this algebraic fraction. So the first thing we want to think about is looking at these denominators. How are we going to get a common denominator? So what we can do is we can multiply the first term, which is 1 over x minus 2, by x divided by x. And the reason why we've chosen x is because it happens to be the denominator of our second term. You'll notice that x divided by x in itself just equals 1. So you're multiplying that first term by 1. So it doesn't fundamentally change anything about that first term. There's the plus. Now with the 1 over x term, we're going to use the same method. We're going to multiply it top and bottom by the denominator of the first term, which happens to be x minus 2. So x minus 2 divided by x minus 2, and we're multiplying that. So you'll notice that x minus 2 divided by x minus 2, again, is equal to 1. So we're multiplying 1 over x by 1, so that doesn't fundamentally change. Still equals 3/4. Now the nice thing about this is we've got x times all of x minus 2, we can place brackets around there, and we've got x times x minus 2, and so we find that we now have the same denominators. In the numerators we had 1 times x, which gives us x, and in the second term we had 1 times x minus 2, which just happens to be x minus 2. Now that we have a common denominator, we can bring this together and think about the numerator. So in the numerator, we've got x plus x minus 2. We're going to collect like terms now to get 2x minus 2 over x, open bracket, x minus 2, close bracket, and it still equals 3/4. Now we can cross multiply. So if we do that, our next line in the solution looks a bit like this. And so when we get to this point, we've got the 4 timesing 2x minus 2, and we've got the 3 timesing the x bracket x minus 2 close bracket. So that's what we have here. Now we can start expanding out the brackets. So when we do that, we get this equation. Now you'll notice we actually have an x to the power of 2. It's a quadratic equation. So with quadratic equations, we like to have the quadratic equation equal 0. So because this 3x squared happens to be positive, and we like to keep that positive, what we're going to do is we're going to subtract 8x from both sides, and we're going to add 8 to both sides. And if we do that, we end up with this equation. And what we can do is we can then switch those two around. So we get 3x squared minus 14x plus 8 equals 0. Now the next step, if possible, is to try to factorize using double brackets. If that fails, we might be able to use the quadratic formula. It turns out we can actually factorize this, and when we do the factorization, it looks like this. And with something like this, we can always check to see we've got it right, because we can always expand out the brackets. And you can see the check that's been made here. 3x times x gives us 3x squared. 3x times negative 4 gives us negative 12x. Negative 2 times positive x gives us negative 2x. Negative 2 times negative 4 gives us positive 8. When we collect those and simplify that, we get 3x squared minus 14x plus 8. And that matches up with our original quadratic equation. Now that we have factorized that quadratic equation, we know that either 3x minus 2 must equal 0 or x minus 4 must equal 0. So when we try to solve those two equations, we end up with something which looks like this. So there's the 3x minus 2 equals 0. When we solve that, we get x is equal to 2/3. And for that second factor, which is x minus 4, if it does equal 0, then we solve that and we get x equals 4. And so that is your final solution for the original algebraic fraction question.